Have you ever really thought about what happens when you hit send on an email or you click play on a video? In literally a split second, your computer is having a conversation with other computers maybe thousands of miles away. Today, we're going to pull back that curtain on the incredible, invisible world of computer networks.
So how does it actually do it, right? How does a simple request from your laptop manage to travel across cities and oceans and then get a response back in the blink of an eye? That journey, that's exactly what we're going to map out right now.
Okay, let's take a look at this. Now, this diagram might look a little complicated at first, but don't worry about all the details. Just focus on the path it shows. This is basically our roadmap. It shows the journey your data takes, from your own device out into the wild internet. And we're going to break down every single step.
So first things first, not all networks are the same size, not even close. They come in different scales, and understanding that scale is, well, it's pretty key. We're going to start with the two most important types, the local and the global.
On one side, you've got the LAN, which stands for Local Area Network. This is your home Wi-Fi, right? Or the network at your school or office. It's just a bunch of connected devices in one small contained area. Then, on the other side, you have the WAN, the Wide Area Network. And this is the big one. This is what connects all those different LANs together over huge distances. Honestly, it's what creates the internet as we know it.
To really get a picture of the difference in scale, check out these images. That server room on the left, that's a perfect example of a self-contained LAN. A WAN is what connects that one server room to another one clear across the country or even on the other side of the planet. The internet, really, is just a gigantic collection of all these interconnected WANs.
Okay, so what is the actual stuff that makes all of this possible? I mean, these connections aren't magic, right? They rely on some very specific pieces of hardware that do very specific jobs. Let's meet the key players.
First up, the router. And the key thing to remember about a router is that its job is to connect different networks. Its main gig is being the gateway between your local network, your LAN, and the great big outside world, the WAN, which is, the internet.
The absolute best way to think about a router is as a traffic cop. Seriously, it stands right at the intersection between your quiet little local street and the super busy information highway, and its whole job is directing all those little packets of data, making sure they know how to get out onto the internet and, just as importantly, how to find their way back to your specific computer.
Next up, we have the network switch. Now, this thing might look a little bit like a router, but its job is totally different. A switch works inside a single network. It connects all the different devices on your LAN, your computers, your printer, your servers, to each other. So, if a router is the traffic cop for the whole town, a switch is kind of like the mail sorter inside a single office building. It takes any data coming in and makes absolutely sure it gets delivered to the correct device on that local network, and only that device.
And finally, for any of this to happen, every single device on the network, I'm talking from your laptop to a massive server, needs one of these, a network interface card, or a NIC for short. It's the actual physical part that lets a device plug in or connect wirelessly to a network in the first place. Just think of the NIC as your computer's passport. Simple as that. Without it, your computer has no identity on the network, and there's no way it's getting access. It is the fundamental piece of hardware that makes a connection possible.
All right, so we've met the hardware. We've got our pieces. Now, how do we actually arrange them? Well, how we lay out all these devices is called a network topology. It's like a blueprint. We're going to start with the simplest design of all, the bus.
A bus topology is just incredibly straightforward. It's literally one long main cable, that's the bus, and every single device on the network just taps right into it. Super simple, right? But that simplicity comes with a pretty big price. So yeah, on the plus side, it's cheap and it's easy to set up. But here is the massive catch, and you can see it right there in the disadvantages. It all relies on that one main cable. If that cable breaks, anywhere, the entire network just stops working. Kaput. Plus, the more devices you add, the more your data starts to collide, and everything just slows to a crawl. Okay, so next up, let's look at a design that tries to fix some of those data collision problems. This one is called the ring topology. So in a ring, every computer is connected to exactly two others, and this creates a continuous loop. Data just zips around this circle in one direction, passing from one device to the next till it gets to where it's going. So, the big win here is speed. Because data is only flowing one way, you don't get all those messy collisions you see on a bus network.
But, and this is a huge but, it has the exact same fatal flaw. If any single part of that ring breaks, the entire network is dead in the water. Game over.
So, if the bus and the ring designs are so fragile, what in the world do we actually use today? Well, that brings us to the hero of our story, the star topology.
And here's the brilliant solution. In a star topology, there's no single backbone cable to break, there's no fragile ring. Instead, every single device gets its own dedicated cable connecting it directly to a central hub, which is usually a switch.
And these advantages are exactly why this design is the modern standard. It is incredibly dependable. If one computer's cable gets accidentally unplugged or breaks, who cares? The rest of the network keeps working perfectly. Performance is great too, since the switch sends data only where it needs to go. Now, the main downside is that it costs a bit more for all that extra cable. And yeah, if that central switch fails, the whole network goes down. But let's be honest, replacing one switch is way easier than finding a tiny break in a long, hidden cable.
And that's really the bottom line. The sheer robustness of the star topology is why it is the standard for pretty much every modern network you're going to find, from your setup at home to the biggest corporate offices. It just works.
So, next time you're at your desk, just take a look around. You've got that router from your internet provider, all your devices connected to it with cables or through Wi-Fi. Well, you're looking at your very own star network in action, connecting you from your little corner of the world out to the global web. Pretty cool, right?